Alright, Chem 30, I'm back with this seemingly endless series of videos about acid and base calculations. But we left off previously learning about something called the pH. Remember the pH, I'm going to write in red again. The pH is the negative logarithm of our H plus or H3O plus concentration. Remember, those are the same thing, so we can write it either way. We also learned that if the pH is greater than 7, that's technically a base, because the negative sign, it makes it all kind of wonky, and we end up getting things that have really small exponents get larger numbers. So pH of greater than 7 is a base. pH less than 7 is an acid, because that means you have a greater concentration of H3O plus. Remember that negative sign makes it all wonky. And remember, a pH equal to 7 is neutral. Okay? Why? Well, remember, in pure water. In pure water, the concentration of H3O plus is equal to the concentration of OH minus, and that is 1.0 times 10 to the minus 7 molarity. So when you take 1.0 times 10 to the minus 7 molarity, just pure water, take the negative logarithm of it, you get a neutral solution. All right, that's the pH, but there's more in a solution of acids and bases than just H3O plus. We also have OH minus. And so not only do we have something called the pH, we also have something called the pOH. Remember, little p means negative logarithm. So this is the negative logarithm of the concentration of OH minus. So really we're looking at how does this affect, like how does this work when we're dealing with OH minus? Well, if you're dealing with pure water, the concentration of OH minus is still going to be 1.0 times 10 to the minus 7. So if you have a pOH of 7, you still have a neutral solution. But here's where things are going to get a little bit different. Let's say I had a pOH that is greater than 7. What that means is the concentration of OH is actually less than this. If it's less than that, then you're dealing with an acidic solution. If the pOH is less than 7, it means that you actually had a greater amount of this for the OH, greater than 1.0 times 10 to the minus 7, which means it's a base. All right. Now I probably should have written this a little bit differently. But those two connect, right? Any solution where these two are equal, the pOH and the pOH, or sorry, the pH and the pOH are going to both be 7 if you have a neutral solution because their concentrations are equal. But in a solution that's, let's say, acidic, you would have a pH less than 7. But you would also have a pOH that is greater than 7. If you have a pH that is greater than 7, you would have a pOH that is less than 7. Okay, so you can use either of these to describe the acidity of a solution, but usually we use the pH. But just so you're aware, we do have the pOH. And because we have the pOH, we also have another formula that we can use. Remember the pH, if we wanted to know the concentration of H3O plus, we took what was called the antilog, or we raised it to the power of 10 to the negative pH. We can do the same with the pOH. We can find the concentration of OH minus and it's going to be 10 to the power of negative pOH. So if you're looking at formulas, here's one formula, pOH, negative log of OH minus. Here's another formula, pH to the negative log of H3O plus. Concentration of H3O plus, 10 to the power of negative pH. Concentration of OH minus, 10 to the power of negative pOH. I don't even know if I'm saying pH or pOH anymore. I said so many P's and so many H's. Whew. But those are essentially 4 formulas that we need to be able to work with. Previously, I showed you how to use these 2. So let's just do a couple of quick examples about how we would actually work with these. So example number 1, a solution with a concentration of NaOH equal to 0.25 molarity is made. What is the pH? Sorry, pOH. Told you let's just rewrite that. pOH of this solution. I told you I was like losing it with the pHs and pOHs. Okay, remember, first thing we need to do, NaOH, acid or base. Hopefully you know anything that ends with OH, base. Next question, strong or weak? Strong. Strong, base, stoichiometry. Remember, anything that's strong, base, or acid, we're going to use stoichiometry to help us solve our problem. And so we have a concentration of, or we have NaOH, and it's a strong base, so it's going to totally ionize, or sorry, dissociate into our solution, turn into ions, and we got this. Okay, that's my balanced equation. Now, ultimately what we need to do to find the pOH, we need to find the concentration of OH minus. Now, our concentration of NaOH is 0.25 molarity. We've done enough of these problems now that hopefully you can see this is a 1-to-1 ratio. And anytime you have a 1-to-1 ratio, in this case, you're going to get the same concentration. All right. So now that we know that, we can calculate the pOH. The pOH is the negative logarithm of the concentration of OH minus. And so let's plug this in. The negative logarithm of 0.25 molarity. Remember, punch this in your calculator, do it along with me, make sure you actually know what you're doing. Don't just trust that I'm doing everything right. You probably noticed by watching these videos, I am a pro at making mistakes. Oh, made another one. No units. Remember, there are no units when it comes to working with pH and pOH. So we end up with a pOH of 0.60. Okay? And all this was we identified that we were working with a strong base. We did stoichiometry to find our OH minus concentration, plugged it into our pOH formula. Okay? Let's do another example. This time we're going to do an example where we're given the concentration, or sorry, given the pOH, trying to find the concentration. So, a solution is prepared with a pOH equal to 6.3. What is the concentration of OH minus? Okay, now to solve this one, this is pretty straightforward. We take, we want to know our concentration of OH minus. We're going to go 10 raised to the power of negative pOH 10 raised to the negative 6.3, the concentration of OH minus is 5.0 times 10, 5.0 times 10 to the minus 7 molarity. All right, there we go. That's how we work with these two formulas, but here's what I wanted to show you. Remember, we've talked a lot about the equilibrium that exists in water and how when we add an acid, it doesn't just affect the H3O plus, it also affects the OH minus. And that's what I was hoping you would see up here. And it leads us to another important formula that you need to know. In any solution, the pH added to the pOH of that solution must equal 14. Okay, that's the last formula that I'm going to show you for acids and bases. And this is all because pH is really just a representation of H plus or H3O plus. pOH is really just a representation of OH minus. You have both H plus and OH minus in a solution, and they affect each other because of the equilibrium of water. Let's add that in there. That equilibrium of water means that the manipulation of one thing, maybe the H3O plus is going to manipulate the other thing, like the OH minus. You add an acid, you make more of this, shifts equilibrium, and reduces this. You add a base into water, you make more of this, you shift equilibrium, make less H3O plus. It's all connected in this solution. And this is our last formula that you're going to see of how it's connected. Next video, what you're going to look at is how can we actually figure out essentially everything about a solution in terms of its acidity and basicity. And I'll show you a handy little diagram that I've put together that you can use to help you figure out what you're going to solve. I call it my acid and base roadmap, but that's going to be in my next video, so check that out. In the meantime, practice this. Do some problems, work through it, make sure you know how to use these equations and how to solve problems when it comes to using them. Okay? That's going to be your most important thing before we get to our next video. Okay?